Alright, so this is question 3 of the 2017 Math Methods Exam 1. So we have to show that this expression equals this one here. So to do this we can do synthetic division. So we put 1 here, 1 there, and we do the constants of each of these expressions. So we have x to the power of 3 plus 3x squared minus 4. So we have 1x to the power of 3 plus 3x squared plus 0x, because there's no x expression, and then minus 4. And then this is what we do. Drop the 1 down there. 1 times 1. So we times this expression here, these ones, and then add. So 1 times 1 is 1, we put it there. Add 3 and 1, which is 4. And then 1 times 4 is 4. And 0 plus 4 equals 4. And 1 times 4 is 4 again. 4 plus negative 4 is 0. And that's basically proving that x minus 1 is a factor of this expression. So that will be your working out. And then you can write that x minus 1 is a factor. And then you can get this expression here. So you can write x minus 1. And then this will be a new expression. So it'll be x squared plus 4x plus 4, and then you can factor how you normally would. So we would write that, and then obviously we can see that it has to be plus 2, which equals x minus 1, x plus 2 squared. Okay, so the next question is to sketch the graph of the function on the axis. So we can write y equals this expression here, so x cubed plus 3x squared minus 4. And the first thing you can do is find the derivative of this, so dy dx, which just equals 3x squared plus 6x. And by doing this we'll be able to find the turning points where the gradient equals 0. So this is the gradient here, and you do 3x squared plus 6x equals 0, and obviously we can see 3x and x plus 2 equals 0, so therefore x has to equal 0 or negative 2, so therefore our gradient is 0 when x equals 0, so here, or when x equals negative 2, so here. The next thing we can do is sub these values into the original function to find our points. So if we do sub in 0, we get 0 to the power of 3 plus 3, 0 squared minus 4, which equals negative 4, so therefore our point is right there. And then we can sub negative 2 in, so we can do negative 2 cubed plus 3 negative 2 squared minus 4, that equals negative 8, and this equals 12 minus 4, which equals 0. So therefore our point does end up being there. And then the next part is we recognize our domain is from negative 3 to 0. So we have to sub negative 3 into this expression, which I'll do over here. So negative 3 power of 3 plus 3 negative 3 squared minus 4. So this equals negative 27. This equals 27, and that's negative 4 equals negative 4. So therefore we have negative 3, negative 4. So just here. And we know that it comes up like that. It's stationary at that point there. And then the gradient comes back down like that, and there's your graph.